Hi and welcome to Trig Formulas Day 10. I know you guys don't really like it when I do this, but there was so much for me to write in a little space and I didn't think I'd be able to write it on the computer, so they are already pre-written, but you'll be able to read my handwriting better this way. So today we're still working with the second degree trig equations, so quadratics, except this time we have more than one function. What I mean by more than one function is you're going to have sine and cosine in the same problem, or tangent and secant in the same problem, and you need to learn how to get rid of that. Um, let's see here. So we're going to solve the following trig equations using the reference tables as an aid. So your pink sheet that you have that have all the formulas on it, and your red sheet with your trig identities are going to come in handy. So the first one is 2 cosine squared theta plus 3 sine. Make sure yours doesn't say sine squared because I think it's still a typo on your paper. So 3 sine theta minus 3. It's not sine squared, it should be sine. And when we solve quadratic equations or trig equations in general, we need to have one function when we have the exponent of 2. When I say we need to have one function, I mean we either have to have sine or cosine or tangent or secant, one of them. You can't have sine and cosine or tangent and secant or something like that in the problem. So in this case, I have cosine squared theta and a sine. Since sine is not being raised to a power, we can't make a substitution for sine. We can only make a substitution for cosine squared. And cosine squared using our Pythagorean identity would be 1 minus sine squared theta. So what I've done is in place of cosine squared theta, I put 1 minus sine squared theta. Okay, so you can see that here. This is my Pythagorean identity. I had a 2 out in front, so I still have to keep the 2 out in front. And I bring my 3 sine theta down, minus 3 equals 0. Then I need to distribute this 2. And that'll give me 2 minus 2 sine squared theta plus 3 sine theta minus 3 equals 0. Then I just combine like terms. I have a positive 2 and a negative 3, which gives me negative 1. And I have negative 2 sine squared theta plus 3 sine theta. Well, I never like to have negative x squared values, so I just divide the whole thing by negative 1 to get rid of my negative x squared. And this one, in case instead of x squared, it's sine squared. So I have 2 sine squared theta minus 3 sine theta plus 1 equals 0. And then I'm going to factor that. I factored by trial and error, but you can do it by grouping. If you need to do it by grouping, it would be, we can do it over here on this side, 2 sine squared theta minus 2 sine theta minus sine theta plus 1 equals 0. Oh, can't see that. So I'm going to group it and then group it again. I don't need the equal 0 anyway. I have a 2 sine theta, and I'm left with sine theta minus 1. And here I'm going to pull out a negative 1. So I have sine theta minus 1. So I have a sine theta minus 1 and a 2 sine theta minus 1. And that's exactly what I have right there. So you can do it by grouping or you can do trial and error, however you need to factor. So once I do that, I have, so each factor equal to 0. So sine theta is equal to 1. And here I'd add 1, divide by 2, so sine theta equals 1/2. Well, when sine theta is equal to 1/2, my reference angle is 30 degrees. So sine is positive in quadrants 1 and 2, so I have 30 and 150. And sine theta is equal to 1 at 90 degrees, and I kind of drew my little graph here to kind of help me. And it's only one time, so I only have one answer. So for this whole problem, I have 3 answers, 30 degrees, 90 degrees, and 150 degrees. All right, number 2. I have sine 2 theta minus cosine theta. Here I have a double angle, because it's 2 theta. On the pink sheet, the one that you get on the actual Regents exam, you have 2 sine theta cosine theta is what sine 2 theta is equal to. So I just make that substitution. And I keep my minus cosine theta equals 0. Now, looking at 2 sine theta, cosine theta minus cosine theta, they have a cosine theta in common. So they have a GCF. Pull that GCF out in front. So I have cosine times 2 sine theta minus 1 equals 0. I'll set each factor equal to 0. Cosine theta equals 0. Sine theta equals 1/2 because I add 1, divide by 2. Cosine is equal to 0 at 90 and 70. I just drew my graph here to help me. Or you can use your unit circle, either way. Sine theta is equal to 1/2 at 30 degrees. I'm in 1 and 2, so again, it's 30 and 150. So when all is said and done, this is my final answer. All right, for number 3, I have 2 secant squared theta plus 7 tan theta minus 6 equals 0. Again, I have a tan theta. It's not squared. I have a secant squared theta. Therefore, I need to use my Pythagorean identities again. These are on your pink sheets. Sorry, red sheets. And using my identities, my Pythagorean identities, secant squared theta is equal to tan squared theta plus 1. So, and then need to distribute my 2. So I have 2 tan squared theta plus 2 plus 7 tan theta minus 6. Combine my like terms, I have a positive 2 and a negative 6, which will give me a negative 4. And again, these are factored by grouping or a trial and error. And if you need me to, let's see here, I can do the grouping off to the side. I will have 2 tan theta. 2 times negative 4 is negative 8. So my factors of 8, that will give me to 7 would be plus 8 tan theta minus tan theta minus 4. So group and group. These have a 2 tan theta in common. And I'm left with, oh, so that's a squared, sorry, my mistake there. Tan theta plus 4. Here I need to take out a negative 1. So I have tan theta plus 4. They have a tan theta plus 4 in common, and a 2 tan theta minus 1 is what's left over. And again, that's what I did right there. So tan theta is equal to 1/2 my reference angle, because this would be my reference angle. And when tan is 1/2 is 27 degrees. Tangent is positive in 1 and 3. So I'm going to have 27 in 1 and then 180 plus 27 in quadrant 3 to get 207. And then tan theta is equal to negative 4. And my reference angle is equal to 76. Tangent's negative in quadrants 2 and 4. So I'm going to do 180 minus 76 to get 104. I'm going to do 360 minus 76 to get 284. So ultimately, this is my final answer right here. All right. Back side. Cosine 2 theta plus cosine theta plus 1 equals 0. Well, cosine 2 theta is a double angle. And in this case, because this is cosine theta, we need to keep as cosine theta. So on your pink sheet that you get on the Regents exam, you need to find the cosine of a double angle that is still in terms, is only in terms of cosine. And when I do that, I'd have 2 cosine squared theta minus 1 in place of the cosine 2 theta, plus cosine theta plus 1. So this positive 1 and this, sorry, negative 1 and this positive 1 cancel each other out when I combine like terms. So I have 2 cosine squared theta plus cosine theta equals 0. These have a GCF of cosine. It's no different than 2x squared plus x. So I pull out the cosine. So I have 2 cosine theta plus 1 equals 0. Set cosine equal to 0. And we get 90 and 270, just like on that graph I showed you on the front side of the worksheet. And cosine, 2 cosine theta plus 1 equals 0. I'm going to subtract 1, divide by 2. So my reference angle is 60. And cosine is negative in quadrants 2 and 3. So I have 180 minus 60 and 180 plus 60. So here are all of my answers. Last problem. Here I have another cosine of a double angle. I have 3 cosine 2 theta plus 8 sine theta plus 5. Well, because this is just a sine, I need to keep it in terms of sine. So this time I need to use the cosine double angle with the sine only. So I keep my 3 on the outside, and then I have in parentheses 1 minus 2 sine squared theta plus 8 sine theta plus 5 equals 0. Distribute my 3. So I have 3 minus 6 sine squared theta plus 8 sine theta plus 5 equals 0. So I have negative 6 sine squared theta plus 8 sine theta plus 8 equals 0. Divide by negative 1. There's a couple different ways you can do this. This is actually factorable, but I ended up using the quadratic formula just so you could see a problem with the quadratic formula done, because it's been a while since we've used it. But I'm going back up here, and I'm getting my A, my B, and my C, and I'm substituting in for A, B, and C. A is 6, B is negative 8, C is negative 8. So negative 8, in case you forgot your formula, sine theta is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b becomes positive 8 plus or minus the square root of negative 8 squared is 64 minus 4 times 6 times negative 8. So negative times negative makes positive. So negative 4 times 6 times negative 8 would be plus 192. Plus 64 is 256. A was 6, so 2 times 6 is 12 in the denominator. 256 happens to be perfect square, and it's 16. So I get 8 plus 16 over 12, or 8 minus 16 over 12. 8 plus 16 is 24 divided by 12, which is 2. And remember, for sine and cosine, everything has to be between negative 1 and 1. And 2 is not between negative 1 and 1, so we reject the 2. And we have 8 minus 16 over 12. We get negative 8 over 12. So I get sine theta equals negative 2/3. My reference angle is 42. Sine is negative in quadrants 3 and 4. So we have 222, 2 there, and 318. The hardest part about these problems is getting them started. Okay, we need to get things in terms of one trig function, unless you end up with something like number 4, where you can end up, oh, sorry, not number 4. It's on the front side here. Unless you end up with something like number 2, where it's the sine of a double angle, you have to be in terms of sine and cosine, and you're going to be able to factor something out when you have a problem like that. That's the only condition that you can have 2 different trig functions. All right, we will work on this in class.